Hey team, we are live now, and feel free to start when you are ready.
Hello, everyone. Hello, everyone. Welcome to this live session. My name is Peter Ayo, a developer advocate at Klaytn Foundation. So today we'll be having a live session on blockchain interoperability on Klaytn. And so in this session, we'll be going over the possibilities of how blockchains can communicate with each other, and also how blockchains can fetch, data from the external world into the blockchain, right? So joining me today is Kelvin from the Orakl network team. We'll be doing a deep dive into Orakl protocol and also how to use the Orakl network services, right? So without further ado, let's get started, right? All right. So I want to welcome everyone to this session once again, and especially a big shout out to our amazing builders who are building amazing products and use cases on Klaytn. As we all know, Klaymakers is our annual flagship hackathon, and so we are also hosting Klaymakers 23 with a prize pool of over 1 million US dollars with various opportunities like incubation, investment opportunities, grants, with a focus of 100,000 US dollars in cash prize, right? So this hackathon commenced October 10 and it will be ending November 30th, right? So a quick FYI is we will not be extending the deadline for this hackathon, right? And for our amazing builders, we have three main tracks, right? So the DeFi track, the real world asset track, and also the Metaverse and gaming track. Also, we have 6 developer bounties thanks to our amazing partners, right, who have spin up their bounties for this hackathon. And what this means is that builders can make use of the product credits of these partners to build amazing products, and also they are opportune to have post hackathon development and also support. During the period of this workshop or this hackathon, we'll also be having different developer workshops, exploring the technologies and also Klaytn ecosystem. We'll be having different live sessions and also, demo day for finalists. And the good thing about it also for people who, rank as first, or for those finalists to be having post hackathon, support and opportunities for them. So if you have any questions about Klaymakers 23 hackathon, you can scan this QR code to get more information about the hackathon. All right. So, and also if you have any question, especially while building, or you have any blockers, you can more like scan this QR code. It takes you to our Discord channel where our team is always available to answer your questions. Right. Okay, so to the business of the day, right? Building with blockchain interoperability on Klaytn. For this section, like I mentioned previously, we'll be having a part where we'll be doing exploration on how blockchains can communicate with each other, right? And also a part where Kelvin will be doing an exploration on how blockchains can also, fetch data from the external world into the blockchain using oracles, and we'll be doing a deep dive into the Orakl, network. Okay, so for this part, we're going over a little bit of introduction, what, why, and how of blockchain interoperability, cross-chain messaging protocol with a focus on layer 0, and also the different use cases that we can build with cross-chain messaging protocol, and also a hands-on section on how we can send cross-chain message with layer 0 from Klaytn, right? So let's jump right in. Okay, so over the past few years, we have seen, an increase in blockchain and also adoption in blockchain in various industries, right? And this innovation has brought about um, various platforms for developers to run their applications on different blockchains based on the application feature that they so desire or requirements such as, security, throughput, and also costs, really. So, however, this blockchain or this innovation, they are limited with the fact that they cannot communicate with each other. So, take for instance, blockchain A is more like a standalone and isolated system, right? It can communicate with another blockchain, right? So this is more like a limitation that we have in the space, and it kind of talks about the fact that blockchains cannot collaborate with each other, or by default cannot, send transactions across each other. And this brings us to the point that blockchains were created as a standalone and isolated system. This being that, blockchains have their own different consensus algorithm, how that data are being validated and also being, added to the blocks. We have different consensus algorithm like proof of work, proof of stake, and all of that. We also have, difference in transaction formats, speed, and also storage. For as many blockchains that we know, we also know that, some blockchains are EVM compatible and some blockchains are not, right? So for blockchains that are EVM compatible, we have different smart contracts programming language, right? So we have, for EVM compatible blockchains, we have Solidity. For non-EVM compatible blockchains, like ecosystems like SUE or Aptos, they make use of Move, and also for, the Solana and Polkadot ecosystem, they make use of Rust. So this really talks about the fact that blockchains, are a standalone and isolated system, right? Which brings the limitation of the fact that we can't transfer liquidity or state from one blockchain to another blockchain, right? So, but how do we come about this, or how do we ensure that blockchains can collaborate with each other? This brings us to the term blockchain interoperability. So, in a little sense, what is blockchain interoperability? Simply put, it simply means that, blockchain can share information, blockchain can share information across different other blockchains. You can seamlessly send transaction from blockchain A to blockchain B, which also means that you can share and exchange tokens, right? Your ERC token, the ERC20 tokens can be moved from, let's say, Ethereum to Klaytn. Your BP20 tokens can be moved from, the Binance Smart Chain to, Klaytn. And this is what we are talking about, right? And also, in a sense, interoperability encompasses, the blockchain ability to communicate with the traditional Web2 off-chain system, right? What do I mean by this? I mean that blockchains will be able to fetch, data from, take for instance, API endpoints in the normal Web2 system, and this API endpoint can contain like the result for maybe a football or a football match. And in this case, maybe you are writing a betting smart contract. You want to be able to fetch this kind of data into the blockchain. And so, considering the fact that blockchain is isolated, like I previously mentioned, we need this kind of ways so we can build, really complex applications, right? So how do we go about this, right? How do we ensure that blockchains can communicate with each other? This brings us to, why we'll be talking about cross-chain messaging protocol. But before then, why is interoperability really important in Web3? So we want to be able to smoothly share information, right, across, say, you 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 mint an NFT on, or you click on the function mint for an NFT on Klaytn, and the NFT is minted for you on your Ethereum, account. That kind of transaction, or you want to be able to take advantage of the ecosystem of another blockchain, or the decentralized application of another blockchain. Another reason why it's important is that you want to be able to view and read transactions across different blockchain. Also, we have scalability and efficiency, right? So considering the fact that the legacy blockchain Ethereum itself has scalability issue with 15 to 30 transaction per second. We want to be able to do more in that transactions can be batched together. Take, for instance, for your gaming application, you want to be able to handle transactions. You need a platform that has immediate finality and also a high TPS, which is what Klaytn gives, right? So this interoperability ensures that blockchains can, take advantage of their unique ecosystems, right? So like I mentioned, how do we achieve this? It brings us to the point cross-chain messaging protocol, right? So cross-chain messaging protocol as it is are, those technology that connects, that ensures that isolated systems like blockchains are connected together, right? And how does this happen? It ensures that they have standardized rules such that they can transfer assets or information between different different chains, right? So how do we go about this? How have we been able to achieve this? Let's say sending tokens from chain A to chain B, or how have we been able to do this? So number one is token exchange among different chains, right? Say you want to exchange your ETH for Clay. The approach to this is, before the advent of bridges, the approach to this is you go to your centralized exchange, deposit your ETH, and convert this or trade this to Clay, and send this Clay from your centralized exchange like Binance to your account on the Klaytn network, right? So this is a little bit doesn't have a good user experience, right? But we also have other approaches like atomic swap using hash time lock contracts, where once the condition is met, the once the condition is met, the smart contract releases these tokens to the users. But once this condition is not met, these tokens are left being reverted to the users. All right, we also have token transfers among different chains, right? So because I said blockchains are isolated, right, and they can't communicate with each other, right? So, but how do we achieve token transfers among different chains? One of the approach with the advent of bridges is, where you lock and mint on stake, for instance, you lock the token on the source chain, and also an equivalent is minted for you on the destination chain. So this is how we've been able to, approach, let's say, token transfers among different blockchains. So a practical example is, wrapped BTC and also wrapped Clay, right? So this is how we've been able to achieve token transfers among different chains. And also we have the burn and mint way also, like we have the lock and mint. We also have the burn and mint also. So other than tokens, right, we want to be able to also transfer data, right? And this data refers to any cross-chain request by a user, especially let's say you want to send a transaction in a single call. This data also includes token exchange and also token transfers, right? So this is what we want to be able to do. Like I said, cross-chain messaging protocol does this, right? But in the meantime, let's look at how we've been able to more like approach blockchain interoperability over the times. We have notary schemes. So notary schemes are like a third-party entity that act as validators, right? So on the source chain and also the destination chain, they verify transaction on the source chain and also ensure that it's being validated on the destination chain. But this notary scheme is kind of susceptible to centralization risk, in that authority is given to the middle chain validators, right? So this probes a centralization risk, and we, as blockchain ecosystem is, we don't want to be faced with centralization risk, right? And also we have side chains and relay chains. So what this does is that we've been able to achieve interoperability in the sense that we can transfer assets from the main chain to the side chain, like Polygon, and also the Polkadot ecosystem have implemented a relay chain and parachain, such that the relay chain are like an independent blockchain with their unique features, and they can send transactions to the relay chain, All right, like I mentioned previously, we also have the hash time lock contract, right? So what this does is that it ensures that once the conditions are being met for the exchange, the tokens are released randomly to the participants. But in the case where this is not met, right, the tokens are being reverted, right? So also let's look at approaches, right? So like I said previously, oracles also are a way where we've been able to achieve interoperability, right? So what this means is that we want to be able to fetch data from more like from the external world into the blockchain, because they are an isolated system, right? Like data like via random numbers and also like price feeds and all of those things. Also, we have bridges, right? So bridges are a way where we've been able to achieve interoperability, but these approaches are kind of limited in their own way, in the sense that for bridges we've been able to experience arcs and all of those things. For notary schemes we have centralization risk, and also for hash time lock contracts we have something like they can only exchange, or they can only function for token transfers, or sorry, token exchanges, but want to be able to do more, right? Want to be able to exchange data. Take for instance, want to be able to send transaction in a single call, right, from blockchain A to blockchain B. So what this means is that what we have been saying, or what I've been saying, is that with blockchain interoperability, right, blockchains can exchange data and information in a secure and reliable manner, right? You can take advantage of the unique features of other blockchain ecosystem, right? So how do we do this in a secure and decentralized way? So this is where we move to layer 0, which is more like an open source protocol for building omni-chain, right? So because we want to be able to deliver messages across different chain in a secure and authentic manner, right? Layer 0 has provided the solution for this problem, right? And the way they've been able to handle it is that we, at the technology level, or the technology design of layer 0, is that it comprises of 3 parts: the layer 0 endpoints, the relayers, and the oracles, right? So what the layer 0 endpoints actually does is that they are like a smart contract deployed on separate chains that layer 0 supports, right? They are more like a smart contract deployed, like I said. So what they're actually useful for is that they are useful for verification and communication across the different chains that they are being deployed. Also, relayers are really, really important in this case, because relayers are those relayers are basically used for fetching the proof of transaction, let's say on the source chain, and they are being sent to the endpoint contract on the destination chain for verification. Now, what Oracle does is that they are an independent verifier, right? So when I say verifier, I mean that Oracles verify the transactions that are being sent from the source chain and ensure that they are correct by fetching the block headers on different chains on demand, right? So with this approach, if you want to learn more about the layer 0 architecture, you can head over to their documentation. So with this approach, as to how we can send tokens and also data across chains, it brings us to the point that developers can now build many cross-chain applications, right? Such as cross-chain bridges, cross-chain lending platforms, cross-chain NFT aggregators, and also derivatives. So we do expect that with this solution and in this hackathon, our developers will be able to spin up a solution, right, for cross-chain applications, right? So also, yeah, we'll be having a demo on how to send cross-chain messages with layer 0 on Klaytn, right? 1 minute. How to send cross-chain messages with layer 0 on Klaytn, right? So let's just jump right in. So for this hands-on session. We have, an article written for this. And so for as many who wants to follow along, you can head over to our website, klaytn.foundation/blog, and go to our tutorial section. You find this, this article. So to follow along in this tutorial, you need to set up your Remix ID, MetaMask, and also, configure your Klaytn Baobab network and Mumbai network, and also fund the respective accounts with Clay and Matic, right? So what we'll be doing in this tutorial or in this, this session or this workshop is that we want to be able to send a message from Klaytn Baobab testnet to Polygon Mumbai, right? And let's see how that works. First, as we can see, we have two, parameters in the constructor, the layer 0 endpoint and also the initial owner, right? So we want to be able to get the address. So layer 0, as part of the architectural design, like I said, is that they have different endpoints deployed on several chains. And so this is the address for the endpoint on Klaytn Baobab, right? And also, due to their design, they also have this destination chain ID, which is used to identify each chain, right? For this, we have this address. Meanwhile, this chain ID is different from the chain ID that we use, in the normal conventional way. But this is just, architectural design for layer 0. So what we want to do is to deploy this contract on Klaytn Baobab and also deploy it on Polygon Mumbai. All right, so let's get to it. We paste this endpoint address and also the initial owner. So this address is the initial owner, right? You hit transact, wait for, you click confirm. So yes, we have that deployed on, Mumbai. And also we want to be able to do the same for Polygon Mumbai. We have that on Klaytn, so we want to be able to deploy for Polygon Mumbai, right? So what we'll do also, make sure you're on the right network, you switch to Mumbai. And so in the case where you are not just doing for Polygon Mumbai, maybe you want to do for Goalie or Base, you can, head over to the layer 0 documentation to check the address, right? So you can copy the right address. So you paste this here, make sure you're on the right network, like I said, and it transacts. Wait for this to go through, right? So confirm. Right, so we have to wait for this to here. So we have it on the blockchain. Now we have this contract deployed both on the source chain, which is Klaytn Baobab, and the destination chain, which is Polygon Mumbai. Right, so the next thing we want to do is connect these contracts together. Right, how do I mean? We want to be able to ensure, seamless communication between these two contracts. And to do that, we have to call the function trust address, right? And to do that, you have to copy the address of the contract on the destination chain and paste it, here. Make sure you're on the right chain, which is Klaytn Baobab. And it transacts. Oh, yes. Okay. Click confirm. And once this is done, we also want to do the same for our destination, contracts also. Paste this. Make sure you're on the right network, which is Mumbai. Yes. Then click transact. Like I said previously, what this does is it ensures, seamless communication. It helps the both contracts to, connect seamlessly, right? So once this is done, the next thing we want to do is to estimate the fees at which we need to send our cross-chain message, right? So to do that, we need to call the estimate fees function. So what this does is it takes in 3 parameters: the destination chain ID, like I mentioned previously, right? So this is the destination chain ID for Polygon Mumbai. We copy this and paste here. So for the adapter parameters, this is actually a design decision by Layer 0. And what this does is that it helps us to be able to customize the gas fees that we need, like to send transactions to the destination chain. And to customize our relay adapter parameter, we have to do some calculation. But in this sense, Layer 0 already provided a default relay parameter for this adapter, right? But to learn how to customize yours, you can head over to their documentation and see the process. Also, so what is the message we'll be sending to our destination chain? Let's say hello world from Klaytn, right? Let's make sure we're on the right chain. Okay. So it call, right? So it gives the amount of gas, right, in way. It gives the amount you'll be paying in gas in way, right? So this is the amount we'll be pasting in our value feed when sending the message to the destination chain. So now to send the message to the destination chain, you click on this send function, right? So we are sending the same string, hello world from Klaytn. That's the first thing. And also you have to be able to copy this, this fee in way into the value field, right? So once this is done, it transacts, and let's see how we achieve, cross-chain messaging to the other chain. Right, so it was successful. All right, so to confirm or to validate that this transaction was successful, let's head over to our Explorer, right, and paste the transaction hash, right? So as we can see, this was the amount we pasted from the estimated fee, right? And also, we can also verify this using the Layer 0 scan, right? Explorer. So Layer 0 provided a scan where you can check your cross-chain interactions or messages, right? So what this does is that you paste the transaction hash from the previous transaction, right? And it shows the status of the transaction. So currently it says pending. So we expect that it should take a little while. Okay, so now we want to be able to validate that our transaction was successful by going to the destination chain, right? By default, what the data is meant to bring is nothing received yet. But because we sent, a transaction in just a single transaction call, we were able to send, hello world from Klaytn to Mumbai, right? So let's confirm that our transaction was successful by clicking on data. Okay, let's make sure that we are on the right chain. That's Mumbai. Yes. Okay. So let's call the function Voila. We have, this string that we sent from Klaytn testnet Baobab to Polygon Mumbai. So we have hello world from Klaytn. So this is pretty much, how we can achieve cross-chain messaging with Layer 0 on Klaytn. So this opens up, a whole lot of opportunities, a whole lot of use cases where we can now build, like I said, cross-chain, applications like lending platforms, aggregators, and also NFTs, right? So this opens a whole lot of applications and use cases. Okay, let's recheck our transaction here. So since this message has been delivered, this status is meant to change to delivered rather than pending, right? Okay, so moving forward, we have come to the end of the demo, right? On how to send cross-chain messages really as zero on Klaytn. I really do hope to see amazing use cases that will be built from this integration, right? So moving forward, we'll be having our next part, which is interoperability with Orakl network. So in this case, we want to see how blockchains can communicate with external data, how they can fetch data from the outside world, data ranging from price feeds to random numbers. And so we're welcoming Kelvin from Orakl team. All right, so over to you, Kelvin.
Okay. Thank you, Peter. Let me share the screen. Actually, I have my slides ready on my screen, so you can stop sharing so that I can share my screen, please. Sharing. Okay, so I'm going to share my screen. Okay, thank you, Peter, for a great presentation. So as Peter suggested, we can communicate between the blockchains, but how about the off-chain world on Klaytn? But before getting to that, let me get a quick introduction. My name is Calvin. I'm currently the Orakl network team lead. Also, I'm a blockchain enthusiast. I've been in the industry since 2016 with all the bears and bulls. Also, I'm a content creator. So I run my YouTube channel where I talk about blockchain and blockchain development. And if you have some specific question about GameFi, I'm sure I can help you with that. I have my course on Teachable, which is the GameFi 101 with like 5,000 enrollments for now. So before we start it, let's get to the very beginning of blockchain. So blockchain is a storage technology and nothing fascinating about that. So with other storage technology like databases, MySQL, Postgres, blah, 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 data is stored into table and the table are connected to each other. And blockchain is stored data in blocks and all those blocks is chained together. That is why it's called blockchain. So nothing really special about that. So at the core, which is a storage technology, it has its advantages and also disadvantages. And we talk about the advantages of blockchain all the time with this immutability, its transparency. But let's talk about the disadvantages of the blockchain technology, which is weak randomness. And in the blockchain world, there's nothing called at the randomness. So if you want to like dive deeper into why blockchain have weak randomness and also how to exploit it, you can go to this link, which I will put in the description of the live. This is like a 4 video, and each video will like 30 minutes long, where I show you why blockchain have weak randomness and how to exploit weak randomness in blockchain. But in the scope of this presentation, let's just assume that there is no randomness in blockchain. Also, with the blockchain world, we cannot bring off-chain data on-chain. So if you work with like programming language like JavaScript, you have something like Access where we can send an HTTP request, and then they have a HTTP response where we get some like other sources of information into your application. But in the blockchain case, there is no off-chain data. If you're programming with Solidity or Rust or Move or C or any languages that support blockchain smart contract programming, there is nothing as a sending an HTTP request and then get an HTTP response to get the data from external sources. So that is the two biggest disadvantages of the blockchain technology. And that is exactly why all blockchain needs some Oracle. And Orakl Network is an Oracle service that runs on the Klaytn blockchain. We are fully compatible with Klaytn. I have to admit that we take a lot of concept from Chainlink, which is a big company and the standard for Oracle, and we optimize it. Also, we twitch it so that it fits the best to work on the Klaytn blockchain. Also, we have VRF, request response, and data feeds. VRF will solve the problem of the weak randomness, so we can call and you can get a randomness properly on the Klaytn blockchain. Request response is you can get any data from any sources of API and bring it to your dApp. And we also have data feeds, which is like we all constantly fits the data to the blockchain and you can read it immediately. And with Oracle service, we support for mainnet and also service chains on the blockchain. And we accept payment in native token, which is the Clay token. So you can start to integrate your dApp right away. You don't have to go on chain and buy another third-party token and then send it, blah, blah, blah. With Klaytn and Oracle Network, you can start building right away. And we are very flexible with payment and subscription plan. We are audited by VeriChain, so you can actually believe that all the smart contract has been audited and there is no security risk by VeriChain. And because we are a new team on Klaytn, so we are always eager to listen and we will support you so that you can have your dApp up and running. So let's talk about VRF, which is verifiable and random number. And you can click on the link or you can scan the QR below. We have a GitHub repo in Bizonai VRF consumer. And actually, let me show you the GitHub. Let's get our hands dirty and try to make a VRF request. So if you come to the link, it will bring you to this repo, which is our VRF consumer repo, where we show you how to request and how to read a VRF. So you can follow all the instruction below and to do all the coding, but this is boring. The thing I want to bring up here is I'm going to bring up my remix. And with this remix, you can click on these 3 lines and then you click clone and then you just paste the whole GitHub repo in here and it will load the repo into the remix console. And because I already loaded, so I'm going to go to VRF and then I'll go to contracts and I'll go VRF consumer. In order to request a VRF, first of all, you need to inherit from the VRF consumer base. And then let's take a look at this specific function, which is the request random word. So this one is this function is the function that you need to call when you need a VRF. So in order to request, you need the key hash, you need the account ID, you need callback gas limit, and the number of words that you want to request. So the key hash, to get the key hash, you can actually here at Oracle Network and you go to account. And this is on Baobab. So I'm going to do a demonstration on the test network Baobab. Because I am an old and frugal man, don't want to spend clay on Cypress. So we have the key hash here, which is the identifier for the Bizonai provide. So if you input, you request the random word with this key hash, Bizonai will spit back the random number. And you have the coordinator address here. So this is the key hash. And what do we need? We need the account ID. So how can we have the account ID? It's simple. You go to this page, connect your wallet, and make sure you have some test faucet on Clay, which is I call T Clay here. I got a lot of those. And you click create account and click it, create account. And then we confirm. And we just wait for the transaction to be mined. Okay, and click confirm. And after you create the account, you need to fund it. So in this case, let's say I'll try to fund it with 10 Clay and I add fund into it. And I click confirm. And the next step after you create the account and then you fund it, the next step is to add consumer. So we need to specify what specific contract address going to be spend the funds in this account. So I'm going to add consumer, or you just do it later. And if you click the refresh button and then you scroll down, you will see that I just created an account 220. And the nice thing about this page is that they have all the red and green dots. So the green dots is this account ready to go. So we already created, you already funded, you already add consumer, which is 3 consumers here. And with this account, this is red because you created it, you funded, but there is no consumer. So it is not ready to go. So by looking at this, you can see what account is available. And if I click here, you can add consumer here. Why I cannot add? Yeah, you can see the information of the account here. Actually, let's try it. So I go back to my remix, make sure that my compiler is right. I compile it. And then I will try to deploy it. And to deploy, you need the address of the coordinator. So you deploy with the constructor, which is the coordinator. So where do we get the coordinator? We get it here by get back to the account page. You see VRF coordinator address. So I'm going to copy this back to here, paste it here, and then I'm going to deploy. Oops, I need to switch to injected provider MetaMask. Click deploy. And then I click confirm. Okay, and we are here. So we already deploy this smart contract VRF consumer. So I copy account, come back here, get to my new account, and I'm going to add consumer. So click here, paste it in here, and click confirm. And let's wait for the transactions. Let me refresh my account, and you can see the consumer is here. So theoretically, we should be able to request a random word. So with the random word, we need the key hash ID. We got it. Callback gas limit is the way that you specify the gas to use for the fulfill function. So depends on how complicated you want our Oracle to fulfill with the VRF, you will put the callback gas limit here. But I'm not going to dive deep into that. So let's get back to the account page. And then I'll copy the key hash, put it here, key hash, account, if I remember correctly, 220, callback gas limit, 500,000 is more than enough. And I'm going to request 1 random word. And I click transact. And I click confirm. So during this time, this smart contract will emit an event, and our off-chain Oracle will catch that event. We process that event to generate a proof, and then we submit that proof back to this smart contract. So why is it called a verifiable random number? Because we don't submit the random value right away, so that in case someone intercepts and they can catch that transactions with the proof, they cannot generate the random work themselves. And if I click as random work, it says it's already like 1. So I have a random work. And that is how we can request a random word from Oracle network. And with random word, we can build many cases. And let me come back to my slide and let's jump right away at the bottom. I will put all these links in the description below. So this is one product that we build from the front end API and back end smart contract, blah, blah, blah. We build with VRF on Baobab. You can scan the QR code or follow the link for the code. This is called the flip coin game that you can actually play here on Baobab. So you connect your wallet, you select, you want to flip the coin with heads or tail, you select the number of clay that you can put on the bed, and then you click flip. And then it will like use the VRF service to flip the coin. So if it's, we randomize the number. If it's a odd number, it's the head, and it's the other way around, it's the head, it's the tail. So you click confirm. And then you wait for it. You wait for the randomness to happen, and then we get back the result that you double your 3 clay or you just lost it all. And it seems like I'm really lucky here. So I have double my 3 clay, it becomes 6 clay. And if you click here, you can see all the transactions that happening on chain, which is right here. So we do all the interactions with the sets of smart contract from Orakl network, gets account from the prepayment increase now. If you want to be more detailed, you can actually click here and you can check everything on chain. And then you can come to the reward and then click the claim button to claim the clay that you win. And if you lost, of course, you lost your clay and the clay get locked in the smart contract forever. This is a really simple game. But if I remember correctly, on Solana, there's one game called Degen Conflicts, which works exactly the same. And they got somewhere around like $50 million locked in the smart contract. So it's really interesting how to build with BRF. Okay, let's get back to the slide, and we get back to request response. So it's not just like you can request a VRF, but you can actually request any API. So any API, we will send the request, and then our Orakl network will fetch the data, and then we will come back and then fetch the data for you. So actually, let's get back to my remix console, and then I switch to request response consumer. So if you want to load this, you can just come to our GitHub repo. So you come to Visionai, and then we have the 3 consumer repos separately: VRF consumer, which I just show you, and then request response consumer, also data feeds consumer. So you click request response, you can copy the code and load it directly into this GitHub. So you go to contracts. Let's see what's happening in here. So in this case, I want to get the Bitcoin price from the Coinbase API. So that is how you create the request data function. And with this request data, you just need the account ID and the callback gas limit. Actually, let's try it right now. So let's make sure that we compile it. And then we deploy it with the address of the coordinator. And let's get back to this. We have request response and coordinator address. I'm going to copy this. I'm going to paste it here, click deploy. Oops, I forgot to get back to my injected Web3. Deploy again. And I click confirm. And yep, it's already deployed. And then I copy the smart contract, come back to my account, and then I'm going to add consumer. So I'm going to add another consumer here. Confirm. And let's wait for the transactions. And yep, it is done. So if we hit the refresh button, you should see the smart contract address here. You also have like those 9 statistics, how many clay spent, the last fulfillment from which addresses. Okay, get back to this, and then I come back. So the response, it is at the default value, which is 0. And I'm going to make the request now with the request data. So I put the account ID to 0. And then I put the callback gas limit. It's more than enough. I click transact. and then we already send the transactions. Let's wait for the Oracle network to come back to off-chain data and grab the data and then come back and fulfill the off-chain data into this smart contract. It's not yet, just wait for it. Just wait for it. Yeah, and we get the data, which is the Bitcoin price of today, of the latest round in the aggregate contract in this, from this Coinbase API. So today price is 33,000. Wow, this shit is really high today. And that is how you can call any API, and then you can fit the data of the external API into your smart contract using our Oracle network. So that is like VRF and request response for those two services you need to pay. And actually we have another services which called the data feeds, and it is free. So you can like use it anytime you want, or we call it intermediate read. So with data feeds, as the name suggests, we constantly feed the data to the blockchain. For example, the price of BTC and USDT. If you click on the aggregator address, you can see that we have our infrastructure to submit the Bitcoin price every 30 seconds. So 1 minute, you can see 1, 2, 3, 1, 2, 3, 4, 5 submits here. So we're constantly updating the Bitcoin price on chain. And how to read it? You can read it directly from the proxy address. So let me try it right now. So this is the proxy address that I just put here. If you click the decimal, this BTC and USDT. This address is like 73 AC, and you can see it's right here. So this is exactly the one. And you can just read. And this is reading the value from the blockchain, so you don't have to pay anything. You don't even have to pay for gas. You can just read it by calling the get latest round data. You click here and you get the latest round data. You have the answer is like 3389, really big number in way. And also you get the round ID. So we already submitted to this ridiculous round, which is really often because we submit the price every 15 seconds, and you have all of these data already available on chain. So whenever you want to use it, you just come to the proxy address and then read it right away. And let me show you on the GitHub rip on the Remix console. So we'll come here with the data feeds. And you can clone it by go here, user 9, and then data feed consumer. So we have this consumer already, copy the code. And then you will see how to implement this. So we need a constructor. In the constructor, you input the aggregator proxy address. Let's get back to the deploy, compile it, and then deploy. So I want to read the price of Bitcoin. So I'm going to here, and actually we're on Baobab. So you need to scroll down, and we are on Baobab. We copy the proxy address here, and then we paste it here and click deploy. And we have the data feed consumer. So if we click the get latest data, also I forgot to change this once again. Let's do that once again. Click confirm. And we have the data feeds deploy, and we can call the get latest data. So this is my implementation of the data feeds. You can call the get latest data from the aggregator proxy, and then you can update the state of this smart contract. So we have to pay the gas, which is for updating this value. But if you just read, or you don't want to integrate it into your smart contract, but you can do something like off-chain read, then it's free. So we get the latest data, we get the round ID, we get the decimal, and then we get the answer spit back here. So that is how you can integrate our data feeds here. And if you have a specific data that you want to report on chain, you can go to Orakl network and data feed page and click the request data feeds. And if we receive your request and we see that everybody is in need of this data on Klaytn, so we will run our infrastructure and we'll constantly submit the requested data onto Klaytn. And one last thing I want to show you is with data feeds, we can actually build something like this dApp. So let me get back to the slides. If you follow the links, you can build a binary option dApp by reading the data from data feeds, and you don't have to pay any gas because it's free. So you can, this is as a reference for you guys to build on data feeds. And let me get back to it. And just a quick disclaimer: binary options is illegal in certain countries. So this is just for reference purpose. So let me get back to the data feeds. So the idea behind this dApp is really simple. So you're going to bet on the price. So you see all the paired price here is fetched directly from our aggregator proxy. So if you want to bet on the BTC, you can see it's directly fetch the data from our data feed. And if you want to bet that the price will go up after 30 seconds, you can click start, and then we start the countdown. And after 30 seconds, we can read again from the data feeds. And at this time, the data is already updated and we can compare with the previous price. And if this goes up, then you can win 5 points. If it goes down, you lose your point. And so the concept is really simple, and the code is open source. So if you want to build something like this, there's always, you can reference to this repo, and I'm going to make sure that we put in the description. And yes, the price goes up, so I already win. So you see the Bitcoin price, BNB, and all the data feeds, you can integrate it in here. And also what I'm going to share, because we still have like 3 minutes left. So if you want to be tricky and you want to go to our GitHub repo, let me switch to the VRF and request response consumer. So we have consumer here. So we, in the script folder, we prepare some amazing script for you, and you can do something like get the account. You can create and fund your account directly by running the scripts. You can get the estimate the service fee. So if we're wondering how much it will cost for one VRF request on Cypress at the moment, you can run the script and we can estimate how much this is cost. So for now, with the current configuration, you will get 2 Clay on Klaytn. And there's a bunch of script. So feel free to just clone our open source repo and play around with it. What else wanted to show you? And I think that's it for these demonstrations. So in total, you can use VRF, you can use request response, or you can read from any of the data feeds that we are running. Thank you guys for listening.
Oh, awesome. Thank you, Kelvin, for that amazing, hands-on session on how to use Orakl for different, Orakl services that you guys have, from VRFs to API requests to price feeds. Awesome. Right. Okay, so let me just quickly share my screen. Okay, nice.
Yeah.
Yep, thank you. All right, so once again, thank you, Kevin, for that amazing, workshop and so on. I will want to quickly say that happy hacking, to everyone building amazing use cases on, Klaytn, especially this time, Klaymakers 23. And also, we expect that you guys stay tuned for more live sessions. And as we all know, today is for building with blockchain interoperability, as we've concluded. So coming up next is, open source DEX and transformative use cases, right? To be coming up October 31st, right? So please do plan and prepare to join this workshop. Also, we'll be having different workshop also coming on and live sessions, but we'll keep everyone updated. Just kindly follow up on our social media platforms, Twitter, Telegram, Discord, so you can catch up with this information. Right. Also, we'll be having the live demo sessions for each track, the DeFi track, RWA, Metaverse, and gaming. Then finally, we'll be having a closing and prize ceremony, right? So I really do wish all the builders, good luck and also Godspeed, even while they are building their amazing use cases. All right. So if you have any question, like I mentioned before, or you've got any blockers, right, while trying to implement some of these things that we've talked about, be it layer 0 or sending cross-chain messages or making or using the Orakl network for your Orakl services or needs, right, you can always head to our Discord channel where our team is always ready to answer, right? Okay, so we're using this medium to also invite everyone to build with Klaytn, to contribute to the ecosystem, and also because we are 100% open source, we are inviting everyone to build with Klaytn. We have amazing developer infrastructural packages and also onboarding tools, and there are a whole lot of opportunities, right? From grants to incubation opportunities, and also very soon we'll be having our bug bounties coming up, and this is more like an innovative idea for the growth of the ecosystem. So we are really inviting everyone to build with Klaytn, right? So if you have any question, you can scan this QR code and you get more information, right? So thank you everyone for joining, and let's keep building the future of blockchain with Klaytn, right? Thank you. Do we have any questions? Oh, okay. I see no question from the audience. Oh, all right. So that will, be the end of today's workshop and live session. Do catch us on the next one, right? Thank you.